Hello students, in previous class we studied, that is we discussed from chemical kinetics chapter second PU, the few previous year questions we discussed, that is from 2014 to 2017 we discussed. Then we have to the remaining questions what they given in the previous years, that is from 2018 to 2020 we discuss now in this class, right? We study, right? Now see that the question number in your material, that is serial number 13, Kcet 2018, which is from chemical kinetics. That is the value of rate constant of a pseudo first order reaction. That is the question. The value of rate constant of a pseudo first order reaction, which is so that is which is once you see that pseudo first order reaction is, you know that well the molecularity is 2 but order is 1. So higher order which is contributing to first order is also called which is a pseudo first order reaction or pseudo unimolecular reaction, which is right. And pseudo first order reaction, that means the molecularity is 2 but order is only 1, which depends upon only one reactant concentration term, is also called pseudo first order reaction, which is the value of rate constant of a pseudo first order reaction. The given option A depends only on temperature is given. That is the first statement. So first statement, option A is depends only on temperature, which is next option B depends on the concentration of reactants present in small amounts, which is so reactants there when they are present in small amounts, which is, and they given that. And option C is depends on the concentration of reactants present in excess. So whenever the reactants they are present in the excess, especially solvent when they are present in the excess, then which can depends that only which is a pseudo first order reaction. Actually, this statement is the right statement, which is right. And option D is independent of the concentration of reactant, which is. So I am saying here, which depends upon only the one reactant concentration term, that is, so but molecularity 2 irutte adralli, but order is only 1 you have to take here. So one reactant concentration mele when it is takes place here, if the concentration of solvent, especially the solvent when they are present in the excess, large excess, and in that time on that solvent the rate is does not depends here the pseudo first order reaction. Now that depends upon only the solute particle of the concentration. So the solvent may depend on adkoskara molecularity 2 agutte but order is 1 agutte in the chemical reaction of pseudo first order. So that's why the rate which is depends upon only the what is it? Rate depends upon the when the concentration of reactants present in excess, right? And this is about here. Which is option C is the right answer for this question. The value of rate constant depends on the pseudo first order reaction, depends on the concentration of reactants present in excess. That is option C is the right answer. Next question number 14 we have observed here. Right. So what is the given for the reaction? Comma 2SO2 plus O2 gives rise to 2SO3. Comma the rate of disappearance of O2 is 2 into 10 power minus 4 mole per liter per second. Full stop. The rate of appearance of SO3 is, that is the question is given. See, we'll write that first. For the reaction, just you know this already and how to do here, which is in the chemical kinetics. For the reaction, 2SO2 plus O2 gives rise to 2SO3, which is the question. That is, which is the reaction. The rate of disappearance. The rate of disappearance. The rate of disappearance. The rate of disappearance of O2 is 2 into 10 power minus 4 mole per liter per second. Full stop. So what is the rate of appearance of SO3? Rate of appearance of SO3. is, which is right. So option A is given 2 into 10 power minus 4 mole per liter per second. Option B is 4 into 10 power minus 4 mole per liter per second. Next, option C is 1 into 10 power minus 1 mole per liter per second. Right. And option D is 6 into 10 power minus 4 mole per liter per second. Right. And which is the question? So see that read the question here. So 2018 they given, which is if the related questions if they will ask means in the future exam, that is in your exams, and you have to do how to solve here like this type of questions here. See, for the reaction 2SO2 plus O2 gives rise to 2SO3, and the reaction is given, which is then the rate of disappearance of O2, actually the reactant concentration is disappearing while going on reaction. That means decreasing the concentration of reactant. At the same time, while going on reaction, increase the concentration of the products. That means the rate of disappearance of O2, how much disappearance O2 is, that much is given, that is 2 into 10 power minus 4 mole per liter per second, full stop. The rate of appearance of SO3 is, appearance of SO3, that means product concentration, how much increases, right? Which is disappearance of with O2 here. Then we have to take the first equation, which is 2SO2 plus O2 gives rise to and 2SO3. Here the relation for this first the rate is equal to, which is minus 1 by 2 d concentration of SO2 divided by dt is also is equal to minus d concentration of O2 divided by d2 is equal to dt is equal to plus 1 by 2 and rate of appearance of SO3, which is d concentration of SO3 divided by dt, which is right. And this is the actual rate here with respect to, but the question is given with respect to the oxygen, with respect to the rate of appearance of SO3. Andre, that means the relation is here, that is a d concentration of O2 divided by dt minus then is equal to plus 1 by 2 d concentration of SO3 and dt. But the given here, which is rate of disappearance of, O2 is given. How much it is given? 2 into 10 power minus 4 mole per liter per second is equal to, which is, and plus 1 by 2 d SO3 concentration of SO3 divided by dt, and this is the relation here, which is. Then we want what is the rate of appearance of SO3 we want here. That means d concentration of SO3 divided by dt is equal to, which is, and which is cross multiply, we have to get here, and these two come in here, which is 2 into 2 10 power minus 4, right? And we have to get here 4 into 10 power minus 4, which is mole per liter per second, which is the answer. Option B is answer, 4 into 10 power minus 4 mole per liter per second, which is. So the rate of appearance of SO3 is equal to 4 into 10 power minus 4, that is, which is right. So this is the answer here. Question number 14 is this. Next, 2018 only one more question is given. Once you see that one more question, what is that? Right. Question number 15 in the serial number. The temperature coefficient of a reaction. The temperature coefficient. The temperature coefficient of a reaction is 2. Full stop. The temperature coefficient of reaction is 2. When the temperature is increasing from, when the temperature is increasing from 2 increasing from 30 degrees Celsius to 30 degrees Celsius to 90 degrees Celsius. Come on. The rate of reaction increased by the rate of reaction increased by the rate of reaction is increased by which is yes, option A is given, which is 150 times. Option B is given 410 times. Right. Option C is given 72 times. Next option D is given, which is 64 times. Right. And which is the question? See, the temperature coefficient of a reaction is 2, which is temperature coefficient of reaction is 2. That means every 10 degrees Celsius rise the temperature by 2 times, which is double the rate here, which is the rate is doubles by increasing the 10 degrees Celsius temperature, right? Which is so that is the term given. The temperature coefficient of reaction is 2 here, which is full stop. Then when the temperature is increases from 30 degrees Celsius to 90 degrees Celsius, so 30 degrees Celsius and 90 degrees Celsius temperature rise again. Then the rate of reaction is increased by how many times? Which is so we have the formula. Then 2 power n here, which is the formula. 2 power n here. So where n is equal to, therefore n is equal to, which is how many times increase the rate of reaction when temperature is increases from 30 degrees Celsius to 90 degrees Celsius. The rate of reaction is increased by how many times? But temperature coefficient of reaction is given. That means, and which is temperature coefficient of reaction is 2. That means so when temperature is increases, then how many times we increase the rate of reaction? That is 2 power n times. So what is n here? Where n is equal to T2 minus T1 divided by 10 here, which is that is T2 minus T1 divided by 10, and we know that which is T2 is equal to how much here? 90 degrees Celsius. 90 minus 60 T1 divided by 10, nothing but which is 30, which is T1. Then 90 minus 30 divided, which is nothing but 60. 60 divided by 10, nothing but 6 times. So n is equal to 6 here. N is equal to 6. Nothing but 2 power 6 times. 2 power 6 is equal to what is nothing but 64 times. Which is called, and option D is the right answer, which is option D is the right answer, which is right. So like that here. So when temperature coefficient is 2, then how many times increase the rate? That means the rate is increasing by 2 power n times, which is a formula. Right. So n is equal to where? Which is T2 minus T1 divided by 10. Why? Because every 10 degrees Celsius rise to temperature, right? And the rate is doubles here. That's why n is equal to T2 minus T1 divided by 10. You have to take. Then we get the n value. N is equal to 6. Then 64 times you want, which is 2 power 6. Which is option D. Right? Kcet 2019 we have discussed now. So from the for 2019, so what they given the questions from chemical kinetics. Question number 16. Right. Which is wrong statement they given? Which is wrong statement? Which is, so you should just you have to read the question. Which is wrong statement? Option A. Option A is given. Rate constant K is equal to Arrhenius constant A, which is option A. Rate constant K is equal to Arrhenius constant A. If EA is equal to 0, if EA is equal to 0, then option B is ln K versus 1 by T plot is a straight line is right statement also, which is option C is given, which is e to the power of A by RT, which indicates the fraction of molecules gives the fraction of reactant molecules. Reactant molecules that are activated at the given temperature. Right. Next, option D is given presence of catalyst. Presence of catalyst will not alter the value of EA, which is right. Then this is the question here. So he asked the question, which is a wrong statement? See, the first option, what is the given here? Rate constant K is equal to Arrhenius constant A if EA is equal to 0. So then actually Arrhenius equation is K is equal to A E and minus EA to the A by RT, which is, so this is K is equal to rate constant of Arrhenius, then A is equal to Arrhenius constant, then which is minus E power minus EA by RT. EA is equal to activation energy and R is equal to universal gas constant, that is T is equal to absolute temperature, which is right. So first statement, rate constant K is equal to Arrhenius constant if EA is equal to 0. So whenever EA is equal to 0, so 0 by nothing but RT, nothing but 0, then E power 0 nothing but 1, that means nothing but what is it now? K is equal to A, and it's also right statement, which is, but he asked which is that question, wrong statement you want. ln K versus 1 by T. Plot is a straight line, which is ln K versus, which is ln K versus 1 by T curve, which is a straight line, which is right. And this is a graph here, which is also right statement, which is gives you right. Next, E power EA minus EA by RT gives the fraction of reactant molecules that are activated at the given temperature. So at the given temperature, which is fraction of molecules are which is activated, and this can information E to the power of minus EA by RT when it gets the Arrhenius equation, fraction of molecules here. Fraction of reactant molecules can indicate that terms of, that is E power minus EA by RT in the Arrhenius equation, which is also right statement. And presence of catalyst will not alter the value of EA, which is the wrong statement. This is the wrong statement here. So actually the presence of catalyst which speed up the reaction actually. So catalyst can speed up the reaction, which can get the rate is very speedily, right? And by decreasing the activation energy, which is by decreasing the activation energy, rate constant increases just, so will not alter the will alter the value of EA is the right statement, but the event will not alter the value of EA, which is a wrong statement is here, right? And coming to see next 17th question, 2019 17th question. To the 19th, 17th question. Once you see that, and in your serial, that is right. From electrochemistry, from chemical kinetics, and you should read that question first, which is 17th one. 1 liter of 2m centimeter, see 2m CH3COH is mixed with the 1 liter of 3m CH5OH to form an ester. Ready? 1 liter of 2m, 2 molar concentration of acetic acid, that means CH3COH is mixed with the 1 liter of 3m CH2H5OH to form ester. First, you have to see that. First, ready? CH3COOH, which is acetic acid, when you are treated with the ethyl alcohol, ethanol, which forms ester, that is forms CH3COO, C2H5 spoiled plus H2O which is formed, right? But so what is the given? 1 liter, both are 1 liter, and but the concentration of acetic acid is given, which is 2 molar, and ethyl alcohol concentration is 3 molar, which is right, and 2 molar and 3 molar, which is right. Next, right. See, which is 1 liter, that is a mixed method. Then the question is, we have to read that first. The rate of the reaction with respect to the initial rate. The rate of the reaction with respect to the initial rate when each solution is diluted with an equal value of water will be. That is. So, the rate of the reaction with respect to the initial rate when each solution is diluted with an equal value of water would be. Andre initial rate ಏನಾಗ್ತಾ ಇದೆ ಯಾವಾಗ when equal value of water is added to that solution. So whenever the equal value we have to add that means dilution, if you add, that means we add the water in that concentration is reduced to half. That means first the concentration is given 2 molar. So first initial concentration is below that. That is, find first the initial concentration. R1 is equal to K into concentration of CH3, COOH, then concentration of C2H5OH, which is a rate law expression for this equation. The formation of ester from acetic acid and ethyl alcohol. Right. Then which concentration we know initially, that is R1 is equal to K into, which is 2 molar into what is it now, and 3 molar, which is 3 molar, then which is 3, then which is called R1 is equal to 6K, right? R1 is equal to 6K we got here. That means initial concentration is equal to 6 times of its rate, which is, so initial rate is equal to 6K, rate constant. We have solved simply. Then ಮತ್ತೆ ಈಗ ಏನು ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ ಅದಕ್ಕೆ ವಾಟರ್ ಆಡ್ ಮಾಡಿದ್ದಾರೆ, ಡೈಲ್ಯೂಟ್ ಮಾಡಿದ್ದಾರೆ, ಈಕ್ವಲ್ ವ್ಯಾಲ್ಯೂ, ಇವ್ರಿಗೆ ಈಕ್ವಲ್ ವ್ಯಾಲ್ಯೂ, ಇವ್ರಿಗೆ ಈಕ್ವಲ್ ವ್ಯಾಲ್ಯೂ. Whenever the diluted to that, whenever you added the water, its concentration is must be reduced to its half. That means now the R2 is equal to K into your concentration ಏನಾಗಿದೆ half ಆಗಿದೆ, that means 2/2, right? And ಮತ್ತೆ ethyl alcohol concentration ಏನಾಗಿದೆ, which is also what is that 3/2. Then R2 is equal to, which is 2/2 is get cancelled, then 3/2 nothing but 1.5 K, which is right. Then we have to take the relation here. R1 by R2 is equal to 6K divided by, which is 1.5 K. K get cancelled. Then which is R2 is equal to 0.25 times of R1 you have to get here, which is R2 is equal to 0.25 times. Andre artha ಏನಂದ್ರೆ when you add the water equal value, its concentration is reduced to half. Then its initial rate is becomes equal to 0.5 times 0.25 times when you add the water. So, but options are the given here. This is the typing mistake is there here. The 4 options 0.25, 0.25, 0.25 are there. 4 options. Then you have to take the first option. Is option A is 0.25 times. You have to take first option change, first option ಮಾತ್ರ ಹಂಗೆ ಇರಲಿ, ರಿಮೈನಿಂಗ್ ಆಪ್ಷನ್ಸ್ ಅನ್ನು ಚೇಂಜ್ ಮಾಡ್ಕೊಂಡು, ಬಟ್ ಎಲ್ಲ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಏನಾಗಿದೆ ಅಂದ್ರೆ 4 ಆಪ್ಷನ್ಸ್ ಈಕ್ವಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದು ಟೈಪಿಂಗ್ ಮಿಸ್ಟೇಕ್ ಆಗಿದೆ. ಜಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಚೇಂಜ್ ದಟ್. ಆಪ್ಷನ್ ಬಿ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದಟ್ 2 times, right? Option C you have to take that which is 4 times. Then option D you have to change that what they given, which is 0.5 times, 0.5 times. So option A is right answer for that. Right now, and you have to take that. Option D is 0.5 times, option C is 4 times, option B is 2 times, then option A is 0.25 times, which is here, right? Then so like that you have to take here, which is this is the question number 19. Question number 17, not 19. Right. Let's go with the question number 18. Question number 18. Right. The plot of 1/t versus R0. The plot of 1/t versus concentration of R0 versus 1/t. 1/t not T half. T half versus concentration of R naught. But ಎಂಗನ್ ತಗೊಳ್ಳಿ ನಿಮಗೆ ತೊಂದರೆ ಇಲ್ಲ. That is concentration of R naught. ಅಂದ್ರೆ initial concentration versus half life. They given the plot. The plot of T half T1 by 2 versus concentration of R naught for a reaction is straight line parallel to the x-axis. Straight line parallel to the straight line parallel to the x-axis. Full stop. The units for the rate constant of this reaction is the units for the rate constant of the x. The units of the rate constant for the reaction for this reaction is. Slope just plot ಕೊಟ್ಟಿದ್ದಾರೆ T half T1 by 2 versus concentration of R naught, which gives the plot, which gives the line straight line to be parallel to the x-axis. That means its meaning is which is independent of the initial concentration of the reactant. Independent of the initial concentration of reactant, which can follow the first order. So always the half-life of a first order reaction is independent of the initial concentration of reactants, which is independent of the initial concentration. A indicates the concentration of R naught, nothing but initial concentration. So half-life of a first order reaction, half-life of a first order reaction, which is half-life of a first order reaction is independent of the initial concentration of the reactant. That's why it gives the straight line. That what are the units we asked just. First option mole per liter second is there. Second option liter per mole per second is there. Third option C mole per liter per second. Option D and which is per second is there. You know that the first order units, first order rate constant units are we are just only the per second, which is, and that is option D is the right answer, which is. Next from for the Kcet 2020. So what they given the questions we have discussed now, right? Kcet 2020, then question number 19, right? Just read the question. Just the time required for 60% completion of a reaction, first order reaction is 50 minutes. Andre question ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ time required, time ಬೇಕಂತ for 60% completion of first order reaction. ಒಂದು 60% reaction complete ಮಾಡಿಗೆ ಅಂದ್ರೆ 50 minutes ಅಲ್ಲಿ 60% reaction complete ಮಾಡಿಗೆ ಎಷ್ಟು time ಬೇಕು, right? Then the time required for 93.6% completion of the same reaction will be andre the time required for 60% completion of the reaction is 50 minutes andre 50 minutes agide ಒಂದು 60% reaction complete agide 50 minutes agide. The same reaction, what is the time required to complete the 93.6% the reaction will be andre just 60% reaction complete agide 50 minutes agide 93.6% complete agide ಎಷ್ಟು time ಬೇಕಾಗುತ್ತೆ, that is the question here. So according to the first which is first order rate constant base, you have to take K is equal to 2.303 by T log concentration of R naught divided by concentration of R. This is a formula, nothing but A by A minus X. We have to take the formula, which is, so then K is equal to 2.303, but time is given, which is time is given already the 50 minutes here. First find the K here. K is equal to 2.303 by 50. Then log concentration, initial concentration, you have to take 100%. First 100% reaction is there. In that after 50 minutes, its reaction is completed only the 60%. That's why the R is equal to 60%. That is 60. That means 60% at 100 minus 60 you have to take. Then K is equal to 2.303 divided by 50 log 100 divided by what we get here, which is 40 will get. So 100 divided by 40 is nothing but 2.5, which is, so 2.5, which also is equal to 2.303 by 50. 2.303 by 50, which is you have to take the 0.04606, right, which is the value. Then and 0.04606 log 2.5 value we will get here, which is 0.3979. 0.3979, which is right. When you multiply this, the K value you got, which is 0.0183, right, which is. But you got the K value. But you asked me the question, how much the time required? How much the time required to complete the 93.6% the reaction, the same reaction? That means again you have to take this. That is K is equal to 2.03 by T log concentration of R naught divided by concentration of R, which is again we have to take that formula. Time required here. That means K value we got. So T is equal to 2.303 by K log concentration of R naught is 100, which is concentration of R naught divided by concentration of R here, which is. Then which is time is required here 2.303. K value we know that K value how much 0.0183, 183. Then and just log concentration of R naught is 100. 100 minus 93.6. So percentage complete target test which is so 2.303 by 0.0183 log which is 100 divided by 100 minus 93.6 ಅಂದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ ಇಲ್ಲಿ 6.7 ಬರುತ್ತೆ which is 6 ಇದೆಲ್ಲ 93.6 ಅಂದ್ರೆ nothing but 6.4 ಬರುತ್ತೆ right which is. So then 2.33 by 0.0183, this value is you will get nearly 125.8 for 125 point. When you divide this, then you get so log 100 divided by 6.4 value is which is how many times you get here, that is which is 15 point something you get here 15.625, right. Then which is 125.8 log 15, nothing but 1.19 something you get here. Then just finally we have to multiply, you get the answer is here, you get the answer is here, which is 150 times, right, which is time required 150 minutes, so you get here, which is, and the option C is the right answer, which is, so option A is given 83.8 minutes. Option B is 150 minutes just. Option C is 150 minutes given, and option D is 100 minutes is given. Then option C is 150 minutes is the answer. Just right. Next question number 20. 2020 only. In the 2020. Right. For an elementary reaction, for an elementary reaction, 2a plus 3b gives rise to 4c plus d. 4c plus d. The rate of appearance of C. The rate of appearance of C at time t. At time t is 2.8 into 10 power minus 3 mole per liter per second. Mole per liter per second. Full stop. Rate of disappearance of B at t time is will be option A is 3 by 4 3 by 4 into 2.8 into 10 power minus 3 mole per liter per second, right. Option B is 2 into 2.8 into 10 power minus 3 mole per liter. Then option C is 1 by 4 2.8 into 10 power minus 3. Next, the option D is here, which is a 4 by 3, 2.8 into 2.8 into 10 power minus 3, right? Mole per liter. Right? This is the question. So read the question first. What they given here? See, for an elementary reaction, one elementary reaction ಕೊಟ್ಟಿದ್ದಾರೆ 2a plus 3b, 2a plus 3b gives rise to 4c plus d, right? This is the elementary reaction. The rate of appearance of C, always you know that in the chemical reaction, the rate of reactants concentration is decreases while going on the reaction. That means rate of disappearance of A and B is also equal to rate of appearance of C and D, which is so in the while going on the reaction, product concentration is increases. That means the rate of appearance of C at time t is what is around. That is how much 2.8 into 10 power minus 3 mole per liter, right? Which is next the rate of disappearance of B, the relation between B and C only, which is here. The relationship between what is that? B and C only, which is at time will be here. See, first we have to get rate per quantity with respect to B. Decrease in the concentration, nothing but disappearance of B, nothing but 1 by 3 D concentration of B divided by dt is also is equal to plus 1 by 4 D concentration of C divided by dt, which is the rate by expression. We know that rate. So rate of reaction, how to express? We know that already for reactants and products. Then with respect to B and C, which is the rate. Then and what he asked here, just what we given, which is the rate of appearance of C is this much, which is how much? Plus 1 by 4, plus 1 by 4, that is it also is equal to 2 into 10 power minus 3 mole per liter per second, right? Is also is equal to minus 1 by 3 D concentration of B divided by dt, right? Then see, the rate of appearance of C is given 2 into 10 power minus 3 mole per liter per second. Then this must also is equal to, that is minus 1 by 3 D concentration of B divided by dt is equal to plus 1 by 4 into 2 into 10 power minus 3. And this what he asked, the rate of disappearance of B, only the B minus concentration of B divided by dt is equal to 3 into 3 however 3 by 4 2 into 10 power minus 3 mole per liter per second you have to get. This is answer, which is, and 3 by 4 you have to get it. 3 by 4 into 10 power minus 3. See that which is having the first option, 3 by 4 into 10 power 2.8 into 10 power minus 3 mole per liter per second, which is the answer, right? And this is about question number 20 to 20, right? So next the final question in this here, but actually this concept is eliminated syllabus here, but we have to discuss just one time. Just listen. Right. Question number 21, 2020. The rate constant of the reaction is given by K is equal to P Z E to the power of minus A by RT, which is right. Under standard notation, in order to speed up the reaction, which of the following factor has to be decreased? ಯಾವುದು ಡಿಕ್ರೀಸ್ ಆಗಿದ್ರೆ ರಿಯಾಕ್ಷನ್ ಸ್ಪೀಡ್ ಅಪ್ ಆಗುತ್ತೆ, ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಚೆನ್ನಾಗಿ ಬರುತ್ತೆ, right? That is the question. See, the rate constant of a reaction is given by K is equal to P into Z E to the power of minus A by RT. Under standard notation, in order to speed up the reaction, which of the following factor has to be decreased? Which is decreased? Option A is given, which is both Z and T is given. Option B is only the EA. Option C is is T is given. Option D is Z is given, right? Which is. So in that always the rate constant is increased by, the rate of reaction is increased by, which is by decreasing the activation energy here, which is, this is the answer, which is by decreasing the activation energy, which is, so which follows the factor which speed up the reaction, which is order to speed up the reaction, the rate of reaction is increased by decreasing the, which is activation energy in that factor, in that equation, that is Arrhenius modified equation is, which is, that is K is equal to P into ZE minus EA by RT, which is, so, and which is the question is a related concept of this year, which is right now, and these are the chemical kinetics from the chemical kinetics questions are here, right? And we'll see in the next class the few more, that is one more chapter, the new chapter, that is haloalkanes and haloarenes we have to start, right? And which is, right, we'll see in the next class. Thank you.